Part B of the roller coaster problem tells you that the vertical beams are spaced 2 meters apart, and they want you to make a table of values of the lengths of the first 5 beams, okay? Well, if you take a look at these beams here, when you're trying to find the length of the beams, you're really just trying to find how high it is above the x-axis, which means you're really just looking for the y-coordinate of the beam at positions basically like 0 meters over, 2 meters over, 4 meters over, and so on, which means you're really just trying to find the functional value at 0, 2, 4, 6, and so on. So I thought we'd take a look at the calculator. Once again, make sure you're in radian mode here. It's always a good idea to check your graph and make sure that it actually is working correctly. So I put in the equation that we put together from the video. It's 15 cosine. You've got to have everything in parentheses here. So I've got the pi over 50 in its own set of parentheses. I've got the x variable after it. Then I close the parentheses on the cosine, and then I add the 12 to shift the midline up to 12. And so we should be able to make a graph here. I'm going to go to the window. If you go back and you look at the original window, it looks like it's going from 0 over to 50. We want to go at least that far over. If you remember, it actually takes 100 units for it to go through a full cycle from a maximum point to a maximum point. So I think I'm going to have the x go from 0 to 100. And if we look back at the y-coordinate, it goes as high as 27, which we figured out earlier, and it goes as low as -3. So I'm going to have the y max out at I'll have to count by tens here, and I'm going to have the y hit a minimum of -5, and I'll have the y max out at 30. And so if we graph this, hopefully we should see a graph that looks kind of like the roller coaster. Now, I set my scale up to show the full cycle, so it's going to be a little bit different than what you might have seen on the original graph. But notice here at about 50, it's at -3. That's where it was supposed to be. At 100, it should be back to the maximum height, which was at 27. So we can scroll over here to about 100. Oops. And you can see it's hitting a maximum height of 27. So looks like the graph is doing what it needs to do. So anyway, we're trying to figure out the height of each of these vertical bars. We just need the y-coordinate at 0 and 2 and 4 and so on. So anyway, you could substitute 0 and 2 and 4 and 6 and 8 and so on into the function. This is also a nice option to do with the table. You could start your table off at an x value of 0. And, oops, that's not the table, that's the table. Start your table off with an x value of 0, and we want it every 2 feet, and so we could do that, and then go over to my table, and you can see at 0, it hits a y value of 27, which we knew, right? It goes 27 feet up, so that first vertical bar there is 27 feet tall. Okay, if we go to the next one, notice that it's about 26.882 feet long, and if you look at the graph, it drops slightly, so that vertical bar should be a little bit shorter. And then you can see there, if you move 4 feet over, the vertical bar is about 26.529 feet long, and so on. So really nice option, saves you the time of having to type all that in your calculator.